When laser optics operate under intense laser irradiation, they might eventually suffer from damage. The damaged optical element doesn't work as expected and cause multiple troubles in various laser-based systems. In order to avoid unexpected laser damage, optical elements should be tested before use. How to survive laser damage? There's several possible methods, and S-on-1 is one of them. The ISO S-on-1 procedure is probably the most popular testing option, the de facto industry standard. It is widely used for the estimation of typical laser-induced damage threshold by applying repetitive laser irradiation per single test site. The estimated laser-induced damage threshold thus considers the short-term fatigue effect, so-called LIDT onset. Let's discuss how the S-on-1 test is conducted. The sample surface is divided into virtual matrix of sites to be tested. Each test site is visually inspected under a microscope prior to laser exposure. The test sample is then inserted into the LIDT test station. A fixed laser irradiation level is set. The laser irradiation level is usually monitored by the energy meter. First test site is now exposed using the chosen irradiation level and maximum S number of laser pulses. If sample survives a maximum number of S laser pulses, irradiation is stopped for that test site. To make sure that nothing is missed, the status of the irradiated site is inspected with online microscopy and interpreted as either survived or damaged. Sample is now moved to another fresh site and exposed again using the same irradiation level. The process continues for a fixed amount of test sites, typically 10 or more. Then the system is set to a higher irradiation level and the process continues for another set of fresh sites. During irradiation, the sample is also monitored for damage by using a self-scattered light detector. If the damage is detected, irradiation is stopped and the dose or time required to trigger damage is recorded. The process continues until sufficient damage statistics are collected or all test matrix is exhausted. Collected damage statistics are then interpreted to calculate LIDT dependence versus the number of applied laser pulses, exposure dose. The damage threshold is calculated for different laser pulse classes and then plotted as a function of time. LIDT value estimated for 1000 laser pulses is often taken as typical damage threshold. As with every technique, S-on-1 has its own limitations. It could overestimate LIDT in cases of low defect density or produce not repeatable LIDT values for large samples. Because many test sites are needed for testing, it is not available for small samples, such as fibers or small lenses. Furthermore, short irradiation doses might be insufficient to discover long-term degradation effects. Nevertheless, S-on-1 test procedure is still a good option to characterize defect-driven damage in cases of high defect density. It is de facto industry standard for getting typical LIDT onset values. It also provides knowledge of LIDT changing over time. With slight modification and appropriate failure mode analysis, it can be adapted for optics lifetime testing. Contact Lidaris to learn more about S-on-1 LIDT test and other ways to solve your laser damage problems.